right, I'm going to start doing problems from the homework. All right, I think this will help you guys get in and get that homework done. All right, so let's look at problem 1, Taylor series basic problem 1. All right, I'm not going to do the entire problem, but I am going to go through the worksheet from the workbook. I can't emphasize enough the need to use the workbook, especially during this Taylor series section. Okay, so what we're going to do is we're going to compute the 6th degree Taylor polynomial for f of x equals e to the x, centered at x equals 0. Okay. All right, so the first thing I do is write the standard form. All right, so the standard form of T6 of x. Let's see, you got A0 plus A1 x minus c plus A2 x minus c squared plus A3 x minus c cubed. And we're going to keep doing that until we get all the way out to A6 x minus c to the 6th. All right, the degree, let's see, they talk about the degree in the homework. The degree is the highest power of x. So you can think of this, the highest power of x here is going to be 6. All right, now centered at x equals 0, so c is equal to 0, this reduces down to T6. All right, so let me write this now, just right here. Okay, so that's it there. Okay, so 2. Right now we're going to make the table. You got n, nth derivative of e to the x, nth derivative at 0, and then an. Now I'll write this last little bit for an. Remember, this is fn of c. In this case, c is 0 over n factorial. Oops, doesn't look very good, does it? Okay, let's go like this. We'll go like that. All right, that looks a little better, I'd say. All right. I got 0, 1, 2, 3, 4, 5, 6. Okay, the 0th derivative of e to the x, that just means you don't take any derivatives. It's just e to the x. First derivative e to the x is e to the x. Second derivative e to the x, e to the x, e to the x, e to the x, e to the x. Okay, now we evaluate this at 0. So e to the 0 is 1, 1, 1, 1, 1, 1, 1. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, I got them all there. Okay, so here you can see that in general, fn of 0 is 1, always, for this example. All right, so we have 1 over n factorial. Okay, so this first one is 1 over 0 factorial, otherwise known as 1. 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial, 1 over 6 factorial, and 1 over 7 factorial. Let's see. Is it right? 6? I did too many of those, huh? Oops. Okay, let's do this. Let's do this. Let's put these rows in there. Okay, there. There we go. Okay, so that's 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, 1 over 5 factorial, and 1 over 6 factorial. Okay, so this tells me my 6th degree Taylor polynomial for e to the x centered at 0 is 1 plus x, right? Because this is just 1. This is 1 over 2, 1 over 6, 1 over 4 factorial. That's going to be 4 factorial, right? Remember that 4 factorial is 4 times 3 times 2 times 1. That's 4 times 3 factorial, right? So we just computed 3 factorial, so we just multiply that by 4. Okay, 3 factorial we found was 6, so that's 24. Okay, 24 times 5. Let's see, what's 24 times 5? So you got a 20 there. 20. 5 times 4 is 20. Which is 10, 11, 12, 120. Okay, 120 and 120 times 6. Let's see, we got 0, 6, 7, 20. All right. Okay, so we got 1, we got a half, x cubed. Let's see, we had 1/6 and 1/24, 1/120th, and 1 over 720. Okay, all right, so here's the 6th degree Taylor polynomial for e to the x, f of x equals e to the x, centered at 0, at c equals 0. Okay, so I think you kind of you might see the pattern, right? You might see the pattern. So, yeah. All right, so at the end of problem 2, it has this here, right there. I wrote that right there. Okay. Okay, so if you wrote your answers for a and using factorial notation, you should see a clear pattern. So let's see, what is a7? Okay, so 7, you'd have e to the x, you'd have 1 here, 1 over 7 factorial. Okay. How about a25? What do you guys think? Do you have a 25 here, right? E to the x, 1 over 25 factorial. Okay. All right, so now for the last part, part 3, we're going to write T6 using sigma sum notation. Okay. All right, so we're going to write this thing using summation notation. All right, remember let's see. We stop at 6, and where do we start? That's a 1 there, so we started at 0. So let's say n equals 0. We're going to start at n equals 0, and we're going to go to 6, and we're going to generalize the terms here. This is x to the n over n factorial. And you can check your work by expanding this out. If you get that, you know you got it right.